Our objectives today, folks, are a couple of things. First, we're dealing with dihybrid crosses. So, we need to understand, number one, what a dihybrid cross is. Okay, that's one objective. Second objective is we need to be able to work a dihybrid cross. So in order to do so, our third objective is to determine the gametes that we would have using a dihybrid cross. Okay? So those are our three objectives for this lesson. And probably you're going to see a couple of more things that you learn how to do with genotypic and phenotypic ratios, but we probably already know those. Okay? So, a dihybrid cross. First of all, what is di? Two. Okay? So, a dihybrid cross, you can see right up here, a dihybrid cross is a cross that shows the possible offspring for two traits. We reviewed using Punnett squares for one trait. Okay? The state of Ohio says, yeah, you learn that one trait stuff over in middle school. State of Ohio says when you're taking biology at the high school, you need to be able to do dihybrid crosses, which is two traits. All right, we're going to spend some time working on these two different types of traits. All right, we're going to take some time working on these two different types of traits. In this example, we will cross a heterozygous individual with another heterozygous individual. Their genotypes will be, I guess I should go back and say, the two traits. The first trait we're going to be dealing with is fur color. It is a black fur color being dominant, a white fur color being recessive. Trait number two is coat texture. A rough coat texture or a smooth coat texture. So dominant are black and rough. Recessive would be white and smooth. What would heterozygous be? Think about that. What would heterozygous be? It would be black rough. Because if it were heterozygous, the genotypes would be, give me the drum roll, it's not clicking, would be capital B, lowercase b, capital R, lowercase r. Mixed with one and the same, capital B, lowercase b, capital R, lowercase r. So, that is two heterozygous individuals crossed with each other. Now, step one, okay? And these steps might not coincide exactly with the ones that are in your book, but they should be somewhat close. But step one of the process is to find all of the gametes that can be made from each parent. Remember, each gamete must have one B and one R. Okay? It can be big B, can be little b, it can be big R, can be little r. But each one must have one B and one R. Could we pair two R's in the same gamete? Could we? No, it says that each gamete must have one R. All right? Now, we're going to show you some ways in which to do this. And the very first way is FOIL. Has anybody ever come across a process called FOIL? I see some hands. Jonathan, where do you have foil from? I forget. Brandon? Yeah, you use it in math. Foil. Front, outside, inside, then last. Okay, if you need to write that down somewhere, write that down. Foil. Okay, it's just like what you would use in math, in algebra. Front, outside, inside, last. Once again, front, outside, inside, last. Now, as we're looking up here, before we start foil, I'm going to show you something. All right? Before we start foil, I'm going to show you something. Let's look specifically at these two right here. And I draw this little arrow down here. On these two right here, how many different letters are there? 2, right? I have a big B and I have a little b. So I have 2 different ones. Well, let's look at this one. How many different ones do I have right here? How many different ones do I have there? 2. Good, Linda. 2, right? A big R and a little r. If I take 2 times 2, what is it? 4. So this one will have 4 different gametes. Okay? That wasn't real hard to do, was it? It will have 4 different gametes. Let me show you something else. Let's say it was this. Right here. How many different letters here? There's 1. Can only be a big B. How many here? 1. What's 1 times 1? 1. It can only have 1 gamete. What is that 1 gamete? Big B, big R. See how I did that? This is just to help you with how many gametes. Let's look at another one. Let me erase this stuff. Let's look at another one. Let's go 1. That's going to give me a different amount. Let's go big B, big R, little r. How many here? 1. How many here? 2. So how many gametes will I have? 2. 2 gametes. Now, here's where it comes in. I know for this particular one, for the one that I have up here now, how many gametes am I going to have possible from that one? 4, right? Because I did my 2 times 2. Now, we're going to use foil to do our gametes. Now, what is F? What did I tell you F was? First. Right there. The first 2. The big R and the big B. So what is our first gamete? Capital R, capital B. What is O? Outside. Well, what are our outside ones? What are our outside ones? B and little r. So we have our second one being B little r. What is I? Inside. What are our inside ones? Little b and capital R. What is L? Last. Well, what are our last ones? Little b, little r. See how foil works? That's not too tough, is it? What do you think, Jamie? Olivia, you got it? Understand FOIL? Dylan? Yeah? You guys do? You three, you do FOIL in math? Yeah? All right. So, now we've got all 4 of our gametes. Now, let's see what would happen. Okay, just for fun. Remember, I just did this one, right? I just did this one, and I said 1, I said 2. 1 times 2 is 2 gametes, right? I said that we would have 2 gametes. Well, let's FOIL that. Capital B, capital B, capital R, little r. Let's FOIL that first. Okay? Is capital B, capital R. Outside is the second one. So outside is capital B, lowercase r. Right? Inside is capital B, capital R, and last is capital B, lowercase r. Can you see how, I got an error here. I got an error here. Capital B, capital R. That's a B. Capital B, lowercase r. There's my errors going. Can you see that these 2 have repeated the first 2? Do we need to do it twice? We don't need to do it twice. So then, since those 2 repeated, how many gametes do we have? How many gametes right here? 2. How many did I say we had? 2. Okay? So, that is FOIL. FOIL we can use no matter what, even if we have only 1. Even if we have only 1, we can still use FOIL. Now, if you look at your packet that I handed out to you, what are the possible gametes for capital B, lowercase r? First of all, look at that. Tell me how many gametes we should have. Huh? How many should we have? Well, how do we determine it? How do we determine it? I see some different numbers, okay? The correct answer is 1. How did we determine it? Fletcher, can you explain it? How many different B's could we have? Only 1. How many different R's could we have? Only 1. What's 1 times 1? 1, right? We're going to have 1. Now, look at that. All of them are going to be capital B, lowercase r, right? All of them are going to be capital B, lowercase r. Let's look. Okay? Capital B, lowercase r. FOIL, F. First. O. Outside. Both of those. BR, B lowercase r. Okay? Inside. Capital B, lowercase r. Outside. Or excuse me, last. Capital B, lowercase r. So, based on FOIL, it gives us the same thing, doesn't it? Now, would you have needed to FOIL that to get those? Probably not. Probably not. But if you would have FOILed it, you would have got that, right? Now, let's look at this one. Here is the second one there. How many possible gametes do I have for this one? Lewis says 2. Would you agree with Lewis? I would too. I could have 2 different H's. I can have 1 different T. So 2 times 1 is 2. Now, do you need to FOIL to determine which ones they are? What are they going to be, Linda? Capital H, capital T is one of them. The other one is lowercase h, capital T. Now, looking at this, when I do my gametes, do I need to do the capital H, capital T twice? Do I need to do it twice? No. I can. Do I need to? No. My ratios are going to stay the same. Same thing with lowercase h, lowercase t. I could do it twice. I don't need to. Now, once again, we come back to our dihybrid cross that dad was heterozygous, mom was heterozygous. So let's check this out. What are our possible gametes when we FOIL this? We already did this, didn't we? Didn't we already FOIL this? Excuse me. Our possible gametes were these 4 when we FOILed it. So, where do we put those? Do you see where they are at the top of your dihybrid cross on the back of the front page? See where they're at? Do they follow in that order? Big B, big R, big B, little b, big R, little b, little r. So, we arrange the gametes as so. Okay, it says right here, step 2, arrange all possible gametes for the father on the top, mother down the side. So we have our gametes, father on the top, mother down the side, and your job now is to fill in the boxes. Now, folks, for the dihybrid cross, how many boxes did they have for us to fill in? How many boxes are on this cross right here? Okay, how many boxes? 4 up, 4 across, so that's going to give me 16. So the most possible on a 16, on a dihybrid cross, is 16. This case, we're going to have the most possible. So what I need to do is I need to fill in the Punnett square. So go ahead and do that. You can see that I'm doing it right now. I'm filling in everything with where it needs to go. Okay, still filling in. I'm going to move this just a tad bit down. Okay, come back to my next one. Still filling. Okay, we're going across now. We're going across. So when I fill in my entire Punnett square, it should look like that, as follows. So I have 16 genotypes. Are all of them different? No, not all of them. You're probably going to see some of them are the same. Okay? You're probably going to see some of them are the same. They are not all different. Okay? I'm going to pause my little video here. I'll give you a couple of seconds to fill that back in. Okay, so we've got our cross. We've made our Punnett square, correct? Here's our cross. And remember what each thing means. Capital B means black coat, which is dominant. Lowercase b means white, which is recessive. Coat texture, capital R is rough, lowercase r is smooth. So our next step, okay, our next step is to determine how many of the offspring would have a black rough coat, meaning that they were both dominant, right? So I go through and I look and say, okay, where is a black coat? Let's go back here. Black coat rough. Right here's one. Is this one? Is this one? All of those are black coat rough, aren't they? Because they have both dominant. Black coat rough, black coat rough, black coat rough, black coat rough, black coat rough. So how many black coat roughs do I have? 9, right? So you should have 9 little tally marks in the box on the next page. All right? 9 little tally marks in the box on that next page. Now look up here. My next one is a black smooth coat. Well, if I look down here, what was smooth? Lowercase r, right? So I have to be dominant for B and lowercase for smooth. So I look through here, and where do I find dominant lowercase? Right there. Dominant B, lowercase r, right there. Dominant B, lowercase r. Those are all of them, right? How many did I have? 3. My next one is white rough. So white is lowercase b's, 2 of them. Rough is at least a capital R. So I look at my one. Here's lowercase b's with a capital R. Here's lowercase b's with a capital R. Here's lowercase b's with a capital R. So how many do I have white rough coats? Should have 3 tally marks, right? The final one is white smooth coat. Well, how many of those do I have? I've only got 1. That's the only box that I haven't checked yet. Right there. Lowercase b, lowercase b, lowercase r, lowercase r. So, when I switch to here, you can see that they have these somewhat color-coded for the different ones. And it's a little tough to see those first 2. Those first 2 to tell the differences. But nonetheless, they are color-coded. So folks, if we were to put together a phenotypic ratio, okay, a phenotypic ratio, it would be 9, 3 to 3 to 1. Or you could say 9/16 were black rough. 3/16 were black smooth. 3/16 were white rough. And 1/16 was white smooth. Right? Do you see how we did that? That's how this is the toughest one. Using all heterozygous is the toughest of these dihybrid crosses to do. Now, let's look at this one. Okay, turn the page. Turn the page, you have this exact thing. Okay? You have this exact thing. Maddie, go ahead and read that for me. My voice is kind of...
cross a plant that is heterozygous for both traits with a plant that is homozygous recessive for both traits. Draw a Punnett square to show all possible offspring and determine the genotypic and phenotypic ratios.
Okay, it says a heterozygous for both traits. Yellow is dominant over green. Round peas are dominant over wrinkled. So a heterozygous for both traits would be capital Y, lowercase y, capital R, lowercase r. What would be a homozygous recessive for both traits? What would that be? Little y, little y, little r, little r. So, when we make our crosses, okay, when we make our crosses, we are going to find the gametes for capital Y, lowercase y, capital R, lowercase r, crossed with lowercase y, lowercase y, lowercase r, lowercase r. Now, do you think you can set up that Punnett square with the mom and the dad the way it needs to be? Okay? The way it needs to be. Now, if we set up our Punnett square, let's go through, folks. Let's go through, folks, and talk about gametes. How many gametes are we going to have for this one? We're going to have 4, correct? Can you foil it? Go ahead and foil that right there, and it'll tell you the gametes that should go across the top. Go ahead and do that, and I'm going to come around and check out what you're doing as you're doing it. So, as I come back, oh, I didn't need to have the volume here. There we go. As I come back, when I had my 2 different crosses and I foiled the 2, I know that I'm going to put on the top these different ones. Correct? Now, you might not have them in that order, but does that matter? The order doesn't matter just so you have those 4. Now, what was my other one? Little y, little y, little r, little r. How many possibilities do I have there? 1. And what is it? Little y, little r. Now, if I would foil it, I would have 4 of these, right? If I were foiling it, I would have 4 of these. Do I need to do 4 of these? I would just be repeating myself, right? So basically, since these are all the same here, I don't have to worry about those, which tells me I don't have to worry about these. All I need to worry about is these top 4 boxes. All right? Those top 4 boxes. Now, what I want you to do for your homework, and we'll start off tomorrow with this. I want you to get the genotypic and the phenotypic ratio for that cross right here. Okay? Remember, what are genotypes? The actual letters. What are phenotypes? What you see, the physical appearance. Okay? So, we would see something like a yellow smooth or a yellow wrinkled. Okay? That is your homework for tonight, to finish this square that we have started.